Hi guys, welcome to the first lecture for blockchain. This video will be covering more of the coding aspects of creating blockchain. So the live lecture should have been more about the concepts about blockchain and how it works in general, kind of. And then for this video, we'll be more going into the Python code for making a very basic blockchain. So as you can see here on the left, we have around a 50-line piece of source code, and this allows us to create a very basic implementation of a working blockchain. So just to quickly refresh your memory, kind of. So how a blockchain works is that there's individual blocks, and each block contains data, and usually about transactions that are made for cryptocurrency between users. And then you connect these individual blocks in a long chain, and that's what forms a blockchain. So there's things like Bitcoin or Litecoin, which are like famous forms of cryptocurrency. So that's all how they're built. They're basically long chains of individual blocks, or millions or billions of blocks. So to make that kind of chain, we're going to try breaking it down into sections and to see how we can make or emulate this kind of currency, cryptocurrency. So here, the first part we're going to do is making the individual blocks. So probably from the previous lectures you learned about Python classes, of how to initialize and define a class. So in our case, we're going to create a class called block, and this class will represent a single block in our blockchain. So you should be familiar with the syntax. So we have class block, and here we have to define the values that are contained within the block. So in our case, we're going to have roughly 4 values. The index number is basically the number of the block. So like number 1, number 2, number 3. And there'll also be a timestamp, basically the time at which the block was created. So maybe current time would be 9:21, so timestamp would be 9:21. And then we have the data. Here is usually where we will put the transaction information if you were working with real blockchain, but in our case, we're making a very small scale version, so we won't be dealing with transactions, but more with just general pieces of data. So maybe like a number value, a string, or something that's very small, just to represent that the block is holding something. And then finally, we have the hash value. So if you're not familiar with what a hash function is, it's basically a function we use to kind of encode data. So it's a password of sorts. So we want to protect our data from like other people that we don't want accessing our data. So especially with cryptocurrency and blockchain, it's involving a lot of transactions that use money or I guess currency, e-currency. So we want to protect all that data. So we use a hash function to put in the data within the block, and then we we can produce a hash password, which can then kind of protect our data. So it's a very important aspect of cryptocurrency to maintain security. So keep that in mind. So let's see. So first, we're going to be following the syntax of Python classes. So we'll be defining the block class. Then we have self to indicate the block itself, and then we have the index, timestamp, data, and then we have the previous hash. So I'll get why I say previous hash in a moment. So we have the self.index will be set to index, and then also have self.timestamp, represents timestamp, and have the data with equal to data. Now here we have a previous hash and a hash value. So we have self.previous hash, and we also have a self.hash. Self.hash. So the reason we have a previous and just a normal hash is because the way blockchain is formatted is that each block relies on the previous block to kind of produce itself. So especially when it's forming as hash code, it uses the previous block's hash code as a reference of sorts to produce this new hash code. So you can see that in a blockchain, the individual blocks are kind of connected to each other, so they rely on each other a lot to both pass on data and also produce hashes. So hence why we have one value that holds the previous hash, and then we also have this hash, which is the actual hash for the block. So might sound a little bit confusing, but just stick with me. So we have this, and then here you can see that we use something called hash block. So we'll define how we will be hashing our data. So here we have a define a hash block. Just indicates self. And here we'll be importing a library called hashlib. And what this basically does is it allows you to use just a basic hash function that does it for allows you to produce a hash code for whatever you want. So for example, if you import hashlib and call it hasher, then hasher is basically what we can use to emulate a hash function. So here we can do a hasher and SHA256. So this is just a hash function, and then we have to update the value. So as we said before, each block relies a lot on the previous block. So we will be using to produce a new hash code. We'll be using the index value. We'll also be using timestamp as well as the data. Finally, we'll be using the hash of the previous block. So it'll be previous hash. So and then we'll be returning the final value. So here we listen to me. But this time we'll be initializing SHA as the hash function, and then we actually update the hash value. The hash value. Finally, we return final values. The hex digest is what we use to produce the hash code, so don't worry about that. And then this in total constitutes the block class. And this is what we'll be using to connect the blocks. So we have our block, and then as I said before, so the blocks rely a lot on the previous block. So how about what do we do for the very first block? The very first block will have no previous block, so that will not work. Therefore, we have to initialize our number zero block ourselves. So we refer to this block as a genesis block. So we take a function called create genesis block. This is basically the number zero block starting point for our blockchain. So basically all we have to do is just return block class earlier, and we'll be initializing the value. So for our index, we put in 0, because we're making the number 0 block, and then for the timestamp, we're going to import another library. We called import datetime. Let's call it date. So we use this datetime library to stamp out the current time. So we can put in 0 and then date.datetime now, and then for the data, we'll just put this block for now, basic string, and then we'll just be initializing our hash value with a random value. So this in total will be creating our very first genesis block, which will act as a starting point for our blockchain. And finally, well, not finally, but our next function will be next block. So this is the function that we'll be calling to basically append the blocks onto the chain. So let's see. So we'll be taking in the parameter our last block. So this refers to the previous block. And then what we'll be doing is for our index value, we'll be initializing a couple of values. This index, this time stamp, data hash. So our index value will be equal to the previous block's index value, index, and then plus 1. So this makes sense. So if our previous block was number 2, we want our next block to be number 3. Basically, we just add 1 to the next index. Our timestamp will be the same function above, date time dot now. Then our data will just be it can be anything, but in our case we're gonna spit out kind of what number block we are. So we can put a string to like hi, or I am block number. So we can append our index number, so it represents our block number. And then our hash will be reliant on our previous hash, so our last block hash. So that's what our hash value will be. Finally, we return this overall block. So we call block again. We initialize with a new index, new timestamp, new data, and finally our new hash value. So this is the method that we're going to use to append blocks onto our blockchain and make our next Bitcoin. So these are our main functions that we will be needing for building our blockchain. So now we can start building it. So our initial blockchain variable, we're initializing using the create genesis block. So this, and then we start our blockchain. This is genesis block. After that, we're initializing our previous block to genesis block, so blockchain 0, and the 0 represents our number 0 block, which is genesis block. And in our case, we're gonna make a very small scale blockchain, so we're only gonna create a chain of around 20 blocks. So we're gonna initialize a variable, number of blocks to add. So it's the number of blocks that we want to append to our chain. I'll just say 20 for now. And then finally, we're gonna, to make our actually chain, we're gonna use a loop and then loop through to create 20 blocks. So we're gonna use a loop from I in range, let's say 0, and to our, we say 20, or in a variable, we use number of blocks to add. Here, what we'll be doing is for each of the 20 times, we'll be initializing a block to add, and this will be our block is a function where we create the new block to append. So using our previous block as a parameter, and we'll be creating our new block to append. Is that? And then we actually append the new block. So blockchain.append, blockchain2, and we append our newly created block to the blockchain. Our previous block, so every time we create a new block, we have to initialize our previous block to the new block. Therefore, that is that every time we create a new block, we have to rely on the most recently created block in the chain. So we always have to update our variables. So our new previous block will be the one we created, so we can prepare for any new subsequent blocks that come in. And then finally, this is just for printing purposes, but you can print out like maybe block number, like maybe number 3, number 4, something. Block number something has been added to our blockchain. Just do this in terminal, and you can print out like our hash value, block 2 at the hash. Not exactly right syntax, but that's right, showing you how it works. So every time we each of the 20 iterations, we create our new block and the new blockchain, initialize previous block, next incoming block. Finally, we just print this out for this. So print out block number, and print out associated hash value. And this will be the main source code. So just to go over for the big picture, we create our block, we create our genesis block, and then we define how we add blocks, and then we define our blockchain, and initialize the values, and then just add on as many blocks as we want. And that'll be our main source code. And if you write all of that and then run it in the terminal, then this will be what you see. So you see like block number 1 has been added, number 2, number 3, number 4. So you can see that we've printed the hash values for each newly added block, and you can see that each hash value is different. So every time you add a block, it changes. 6, 4, B, 5A. Just from the first number, you can see that it's different. So this is a form of security. So if we maintain a single hash value for a long time, it might be easier for other people to break through it. So we update the hash value every time we add a new block just to kind of secure our or increase our security of the hash block. So it's just to make sure that people can't like break into our like bitcoins and like manipulate the data. So blockchain is puts a big emphasis on security. So that's why we always have these hash values changing for every new block. All right, so this is a basic creation and emulation of how a blockchain works. So we made the blocks, we've connected them, and we now have a long chain of not a long chain, but we have 20 blocks right now. So if you were to make it 1,000,000, we have 1,000,000 blockchain, and then you can do whatever you want. So you can just kind of be free with that. That's a basic implementation of our blockchain, and probably our video for next week will go more into the complex kind of operations for blockchain. So onto this basic code, we're going to add on more operations that we can do. They're more complex forms of blockchain operations, so just look forward to that. And for this section, I think I should be done. So I hope you enjoyed the lecture, and I'll see you next week.